Okay, so for this final video, we're going to talk about modeling some sort of data that represents a power or a cubic function. So in this particular example, we are given some data that represents the weekly cost in thousands of dollars of printing X thousand textbooks. So that's what we're kind of looking at, the relationship of the number of textbooks to the cost of printing those textbooks. And as with all data that we are going to model, we have data that comes in that we put into a table or a list, and then we create the equation based on that. So if you don't remember how to do this, we are first going to go to our calculators, and we're going to go to Stat, and we're going to edit a list. So we choose Edit, and we have lists L1, L2, and so forth. Now, if you have data in your list already, you would arrow up and hit Clear. Do not hit Delete. That deletes the whole column, and that's not really good. We want to only clear the data that's in there. I've already input all of the data that I needed. So once you input all of the data for the textbook costs in L1, you're going to come back and input the data for the cost in L2. So let me move my calculator for you to do that. These are the data sets that you're going to put in to L1 and L2. So go ahead and try that. Once you get the data entered, we're going to plot this data. So we need to adjust the window, and I always adjust my window kind of based on the data that I'm looking at. So if my X values are ranging between 0 and 27, then I'm just going to kind of shoot for maybe between 0 and 30, incrementing by 3s. That's just what I chose. And my Y values are ranging from 100 up to 221. So I'm going to go a little further past that. I can go from 0 to 225, and I chose to increment by 20s. So that's what I have set my window at. So I would choose Window, make sure that my window is set at that. And the final piece to our puzzle is to make sure that the plot is turned on. So I would go to my Y equals. I can just arrow up, hit Enter, and it's going to highlight the plot. So we're ready to see what the picture looks like. And this is a picture that represents the data that we have in our lists. So you can see that it does have some sort of relationship, that it does have some sort of curve going on. And now what we are being asked to do is to, once we have put this in and kind of determined that, yeah, there might be a model for this, let's go find the regression for this particular model. And we're going to use a cubic function for it. So we go back to Stat, we arrow over to Calculate, and here are my lists of regressions that I can use. There's a whole bunch more of them, but I'm going to choose the cubic regression, which is option number 6. All of our calculators tend to be just a little different depending on which operating system you're running. But for my particular calculator, I do see that, yes, it's talking about my X variable being L1, my Y value variable being L2. I want to store my regression equation, so I want this equation to spit right over into my Y equals. And I can do that using vars or my F4 button right here. We'll choose vars. So if I choose vars, I arrow over to yvars. I am doing function values, so I hit Enter. And I'm going to choose the Y1, so I hit Enter again. So it's telling the calculator to put my regression equation over there on Y1, and I want it to calculate it, please. So we hit Calculate, and here we go. Here is my regression. I can see here that my R squared is telling me how good of an equation I have. How well is this equation? Does it fit my data? And the closer it is to 1, the better the line is, and that's pretty close right there. You can see that for my A's, B's, C's, and D's, these values here that the calculator generated are the coefficients for those letters. So if I were to round this, say, to the nearest third decimal, I could enter the equation into my into an answer. So this is the equation that was generated. If I go over to the y equals, notice that it put everything in here, which I kind of like because there's no rounding issues. I get the best equation based on that. So my equation is already over here on the y1 and it's waiting for me to graph it. So when I click graph, you can see that the predicted equation is being generated here. And that's a pretty close fit. So we have graphed the function using the regression, and now we want to, the next part of what you don't see right here, we'll go back and the calculator or the question says, okay, well, once you get your equation, use that function to predict the cost of printing 22,000 texts per week. So if I predict the cost of printing 22,000, I'm basically replacing x in my equation with 22,000 and solving. There's several ways that you can do this. One of the most recent ways I've discovered, which I think is kind of fun, is to use that value option again. So remember, I am replacing x in my equation with 22. I am saying if I print 22,000 books, how much does it cost? So I can go here to second, trace, choose value, because when I do that, it says, okay, well, what value do you want me to evaluate for x? For what x value do you want me to evaluate? So I choose 22, and it will do the algebra or the substitution for me. And it finds out that when I print 22,000 textbooks, I can expect that it's going to cost approximately 176.3, we'll call it, $1,000 to print. So that's one way for us to evaluate a function when it's already entered into our calculator. And that's how we would model our cubic information.